So here is another question. The pair of linear equations which are given are root 2x plus root 3y is equal to 0 and root 3x minus root 8y is equal to 0, and we have to solve them for x and y using substitution method. So first we'll write them. So root 2x plus root 3y is equal to 0 and root 3x minus root 8, we'll write it as 2 root 2y is equal to 0. Equation 1, equation 2. Okay, so now from equation 2 we can write root 3x is equal to 2 root 2y, or that implies x is equal to 2 root 2 by root 3 into y, this. So this is equation number 3, where we have represented x in terms of y. Okay, now we'll substitute this in equation 1. X is equal to 2 root 2 by root 3 y in equation 1. So putting 3 in 1, we get root 2 into 2 root 2 by root 3 y plus root 3 y is equal to 0. We have substituted this in equation 1. So that implies we have 4 by root 3 y plus root 3y is equal to 0. That implies four y plus 3y. So here 4 and the root 3 into root 3, that is 3y, that is equal to 0. So that implies 7y by root 3 is equal to 0. That implies 7y is equal to 0 into root 3, that is 0, and that implies y is equal to 0 by 7, that is 0. So we have got y is equal to 0. Okay, equation 4. Now if we put y is equal to 0 in equation 3, we have here, if we put y is equal to 0, we will have x is equal to 0 as well. Okay, so here the solution of this pair of linear equations in two variables, it is x is equal to 0 and y is equal to 0. Okay, the solution is x is equal to 0 and y is equal to 0. Okay, so this is the thing. So here is another question on solving linear equations in two variables using substitution method. So the two equations are 4 by x plus 3y is equal to 8 and 6 by x minus 4y is equal to minus 5. So here there is something interesting. So first let us write the equations, then we'll see how how different this question is from the previous ones. Okay, so 4 by x plus 3y is equal to 8. Let's say this is equation number 1, and 6 by x minus 4y is equal to minus 5. Let's say this is equation 2. So in all the previous questions that we have solved, the variable x or y, it was always in the numerator along with the coefficient, whatever it is, 2x, 3x, 4x, 5x, or 2y, 3y, 5y, 9y, like that. Here the variable, that is x, one of the variables, it is in the denominator. Okay, here it is in the numerator, I mean it is like this along with the coefficient 3y, 4y, but here it is in the denominator. So in order to deal with these kind of linear equations, what we'll do is we make a substitution for these parts, these portions where the variable is in the denominator, like this, in these kind of patterns, these kind of arrangements. So what we'll do, we'll make substitutions as let 1 by x is equal to u, where u is a third variable which we assign, which is equal to 1 by x. So let's call it 3. So when we put 3 in equation 1 and 2, we will have 4u plus 3y is equal to 8. 4u plus 3y, because 1 by x is equal to u, so 4 by x is 4u. 4u plus 3y is equal to 8. Let's call it equation 4. And 6u minus 4y is equal to minus 5. Let's call it equation 5. Okay, this. Now from equation 4 we have 4u plus 3y is equal to 8. That implies 4u is equal to 8 minus 3y. That implies u is equal to 8 minus 3y by 4. Okay, we have got u in terms of y. We have got u in terms of y. This is the main principle of substitution method. We express one variable in terms of the other. So here it is important to understand that u is 1 by x. So basically it is 1 by x is equal to 8 minus 3y by 4. But here don't do that first. Keep it u is equal to 8 minus 3y by 4. So let's call it equation 6. Now when we putting equation 6 in here, equation 5, sorry, v, okay, we get 6 into 8 minus 3y by 4, that is here 6u minus 4y is equal to minus 5. Okay, so here there is 4 in the denominator in this portion. So what we'll do is we'll multiply 4 on both sides. Okay, here in both sides of the equation we'll multiply 4. Multiplying 4 on both sides to remove this fractional portion. So we have 6 into 8 minus 3y. When we multiply 4 here, 4 gets cancelled. When we multiply 4 here, we'll have minus 16y. 4 into 4 is 16. And when we multiply 4 with minus 5, we'll have minus 20. Okay, basically we have done this. Okay, this. So now this fractional portion is not there. Now it is equal to 6 into 8 is 48. This is 18y minus 16y is equal to minus 20. That implies here 18 minus 16, that is equal to minus 34y is equal to minus 20. Here it becomes minus 48. That implies minus 34y is equal to minus 68. That implies y is equal to minus 68 by minus 34 comes 2. So y is equal to 2. We have got y is equal to 2. Now when we put this here, 8 into 3y by 4, which is equal to u, we get 8 minus 3 into 2 by 4 equal to u is equal to 8 minus 6 by 4 is equal to 2 by 4, which is equal to 1 by 2. That implies u is equal to 1 by 2. Okay, u is equal to 1 by 2, but here 1 by x is equal to u. That implies x is equal to 1 by u. So 1 by u is 1 by 2, which is equal to 2. So x is equal to 2. Okay, x is equal to 2. So we have got the solution of the given linear equation in two variable as x is equal to 2 and y is equal to 2. So the important thing here is this part, this portion, this variable x, which is in the denominator part of the fraction, 4 by x, 6 by x. Instead of 4x and 6x, we have 4 by x, 6 by x. So for this 1 by x, this fractional variable, we made the substitution this. We created another variable, a third variable u, for this fractional portion. Okay, we made the substitution, we converted it into simple format, 4u plus 3y is equal to 8, 6u minus 4y is equal to minus 5. But it's important to remember this relationship, that u is equal to 1 by x. So then we solved for u and y. We solved for the values of u and y. So we got the value of y first, then we got the value of u, then using that value of u, we calculated the value of x. So we got x is equal to 2, y is equal to 2. The solution of these two linear equations in two variables, they are x is equal to 2, y is equal to 2. Okay, so this is the thing.